Good afternoon, everyone. Thank you all for attending in today's webinar. Lander, could you please introduce our project background for everyone?
Yes, thank you, Nana. Indeed. So I am Lander Govaerts from Govaerts & Co. And we co-host this webinar with Nana on the SIP3 within the Farmtopia project. So the Farmtopia project is a European Horizon Plus project where we as Govaerts & Co., a small advisory firm in the agricultural sector in Belgium, collaborate with KU Leuven, the Catholic University of Leuven, where we are piloting and co-developing a solution to take professional agricultural information, and specifically on goat and sheep rearing, where we packaged it in a Wikipedia type structure or digital platform. And my colleague Nana from KU Leuven, she built an LLM integration on this platform so that farmers themselves, especially from small and medium farms, can get access to these this information in a acceptable quality-wise, but also a very approachable way. So farmers can ask questions directly to a chatbot/system instead of diving into literature where this is more troublesome for most farmers. Okay. Nana, could you go to the next slide already?
Okay, next part, right?
Yeah.
Okay. So, thank you for Lander share the project background. And now I will take into on this LLM-based goat health assistant on the Capripedia platform. My name is Nana, and I'm from KU Leuven. My supervisor is Professor Thomas Norton, first, I introduce our main objective of implanting a large language model to make the knowledge of goat farming more accessible and generate more applied insights. LLM enables goat farmers to better understand and optimize the key aspects of production, such as nutrition, rearing practices, health management, and so on. Then drive productivity and sustainability improvements in goat farming. Our initial release is a test-based LLM assistant designed for goat farming, providing real-time expertise to users. At level 2, our answers natively support test visuals and structured data. Our training data is based on 125 expert-written articles from Capripedia, all focused on goat health management. As you can see in this chart, the data covers 5 major categories: nutrition management, disease prevention and treatment, goat milk management, ring management, and basic farming knowledge. Nutrition management makes up the largest portion with 68 articles, 54%. Disease prevention and treatment comes in second with 30 articles, 24%. Together, these all articles form the knowledge brain of our assistant, ensuring its professionalism and reliability in answering these scenario questions. Some articles contain 56 tables, but LLM can't read them well, so we need to convert the table into text. Since many table headers are in abbreviated form, we first use the rule ng to decode their meaning and define mapping rules. The table and rules are then input into the LLM. We get a textualized version of the table. We have 5 articles in the form of decision trees, but the LLM can't understand them directly. So we need to convert those decision trees into natural language test. The decision tree textualization rule states if a question lacks any non-leaf nodes in a subtree, the system asks the users to fill in the missing information. If all information are present, the system provides a diagnosis. If any information is missing, the user is asked to provide it. For multiple missing information, all are listed. On the left, it shows the subtree from our decision tree. On the right, with the test is transformed from the decision tree. From 5 decision trees, we identified 58 subtrees and generated 180 question and answer pairs. As you know, AI is known to hallucinate. It makes things up. How can we trust it with our livestock? This slide explains our core defense mechanism, the RG framework. If you look at the technical diagram, it looks complex. But for the farmers, it guarantees a 3-step safety loop, as shown on the left. First, secret priority. Our system doesn't browse random internet rumors, as you can see in the right indexing box. We have locked the AI's primary access exclusively to Capripedia's database. Second, real-time fact check. When a farmer asks a question, the system performs a vector similarity search in seconds, presented by the purple and the blue boxes. It maps the query directly against our certified data. And the third, error-free output. The LLM inside the yellow box acts purely as a translator. It takes the verified data and turns it into a simple action plan. It will never guess or hallucinate. In short, we take the power of a modern LLM and fenced it inside a bulletproof safety cage, backed by the best sources available. The goal of Level 2, to have the LLM generate answers that include not only text, but also corresponding images. If images can be vectorized and stored in the same way as text, we can still implement it using the RAG framework. We first direct the images in words, and then we process the text. Like this workflow. We store these images separately in a dedicated directory. For each image, we generate a textual description. And because the description is text, it can be embedded in the URL and stored in the vector database. When user inputs a question, the system queries the vector database to retrieve the most relevant chunks. At that point, the LLM steps in to determine whether any of those chunks are associated with images. If they are, the system retrieves the corresponding images from the image repository and incorporates them into the answer. If not, the model simply produces a text-based answer. This is an example of a description. So the description is about the image of description, and the very important is keywords and image URL. Because in this workflow, just return the image URLs, not return the images. Mm, we compare the reference answers with the model's answers using semantic similarity. If the similarity is 85% or higher, we mark the answer as correct. Otherwise, we marked it as incorrect. As you can see, the RG-based model achieved validation 87% accuracy and 84% text accuracy. These results clearly show that the RG-based model outperforms the baseline, boosting accuracy from 10% to 84% under identical testing conditions. Here are some examples. First is about disease prevention and treatment. When we ask ChatGPT a question, like my lamb has mild diarrhea, what could be the cause? You can see the answer on the left. It is very long and packed with text. It lists every possible reason, like diet changes, stress, and so on. But it's too messy, and it's hard for users to find the main point at a glance. Now, take a look at the right side. This is the answer from our AI assistant. Its performance is precise. It doesn't just instantly nail down the most key possibilities. The smartest part is that it actively asks follow-up questions. By asking about the duration of the diarrhea and whether the lamb shows signs of weakness, it helps the user rule out causes step by step to find the real issue. This is the advantage of our AI assistant. No useless words, straight to the point, and interacting with users just like a real expert. This is an example of nutrition management, focusing on zinc deficiency. Just like before, our model directly points out the zinc deficiency issue. It's simple and straight to the point. When goats lose their appetite and develop fatty liver after the Q fever vaccine, it's actually a vitamin deficiency issue. However, the ChatGPT gives a lot of information, but it misses the vitamin deficiency. On the other hand, our assistant provides detailed, actionable steps to fix the problem. In this goat milk question, the model's answer isn't the ChatGPT's answer isn't wrong, but it's too messy. It's hard to read and hard to find the main point. But our answer is very clear. And for this basic farming question, the ChatGPT may not even know it's about goats. But because our assistant is specifically trained for goals, it can give you a much more accurate answer. Finally, our RG framework hit over 84% accuracy. We've also built a dynamic knowledge base that stays current with emerging disease and climate trends. Thank you for listening. Do you have any questions?
I do have a question, Nana, then from our side, seeing as we're colleagues, we worked on the interaction with the farmer and you worked on the technical side, but I was wondering, the accuracy figures that you gave, are they tested for questions on which you knew there were articles in the system? Because the system contains between 100 and 200 articles on specific items within goat farming and sheep farming. But if I were to ask a question which is not already mentioned in any of the articles in the database, what would the accuracy then be?
That will be low. But because our you can see this slide. Actually, LLM just acts a translator. It just turns this information into a actionable plan. It just let this it just makes this information easily to read. It doesn't to guess. So if we don't have this information, you ask a question. This question doesn't include the articles. It will search on the internet, but the internet is not the rumors. We set some very authoritated website. The answer will from this websites. But accuracy we can't. Maybe a little low. But we can when we find this question is new, and we can give it the correct answer, we can add to our knowledge base. Next time when someone asks the same question, we can give them the correct answer.
Okay, yeah, so that's indeed very interesting, and the way we should move forward with this initiative after this project ends, because the project ends in August this year, is that we need to fill out the database to contain a complete codex, let's say, on how goat and sheep are farmed within our production settings. And then the mechanism that you proposed, Nana, is very interesting in that regard, that when a question is asked to the system for which there is no article yet, this is then shortlisted or somewhere registered so that it can be picked up by any expert or farmer that is contributing to the system, so that we can fill out the system and make it comprehensive. So indeed, I think that's the way to go on that front. So thank you.
Okay, thank you for your question.
Okay, maybe if there are no more questions, I can, from our side, make some closing remarks, so that if you want more information on the project itself, you can visit farmtopia.eu or visit any of the channels from Nana's research department, but also Govaerts & Co. on LinkedIn and on our website. This information on this presentation can be shared to anyone who is interested. So if you are interested, you can send an email to lander@wimgovaertsandco.be. This might be difficult to spell, but you can find it also on our LinkedIn page on Govaerts & Co. So that's from our side. Thank you for being here and being part of the webinar that displays the work that Nana and Kay Leuven has done on our project. And thank you, Nana, for your obviously very useful work and very nice results, especially in terms of accuracy. This is very impressive and is a real extension to the work that has already been done on trying to disseminate and commercialize or spread the expert goat and sheep farming knowledge that is present in the Low Countries, also to other farms that are maybe smaller and don't have the access to this information in a professional manner. So thank you.
Thank you for attending in today's webinar. Bye.
Okay, thank you. See you all.